Let's do today's daily. There's one laser beam between two security. Device if both conditions are met. Two devices are located on two different rows, R1 and R2. Okay. For each row I, where for each row I where R, so there is no security devices in R. Okay. Okay. Wow. One, two, three, four, five, six, seven, eight. Okay. Okay. So basically, you have to calculate how many H, right? Okay. So we are going to create the beam as much as possible because we want to return the total number of the laser beams in the bank. And there are two restrictions. So when we try to create this beam, we need to check for these two conditions. So the row 1 should be smaller than the row 2. And the other condition is that there is no security device in the ith row, in the between of these two row, right? And yes, so in a brute force way, we can just go through each device and go through each device pairs and check if it's valid or not, right? And by doing so, that would be 500 times 500. And we also need to check if there's other laser in the between row. So perhaps would be n3 power n power of 3. I don't think that would be 100 times 500. 500. That's no, actually 75. 1, 2, 3, 4, 5, 6, 6. Right. I think it's not that bad. So yeah, maybe we can try to do so. And for quickly look up, is there any beam between these two rows? We can use a hash map. And for optimization, perhaps we can use the prefix sum for that. But for the initial method, let's just use a hash map to record is there a device in that row or not. Right? Okay, so perhaps we can just use a list to do so. Okay, so device is device 0 times force length bank. Let's make this variables and well, yeah. Ferrari. Okay, so now we are doing the collect all devices position, and next we want to go through each pair and see if it's valid. So we have a ins 0 turn. Okay, so we are for I devices. Right. Okay. So here, if bank RC equals to 1, let's see. D1 is D1R, D1C is 0, 0. Okay, actually just like this, right? And D2R, D2C, this is J. r not equal to d2r, if d1 are equal to, okay, smaller than d2r, well, okay, valid, go to true. This is the first condition. For r in range d2r, d1 r plus 1, if this device are valid, false, break. If not valid, if valid, then this one. Okay, so we missed something. It's device here. So device, if device are right, that'll be it. Okay. I hope the time complexity will not be too bad. Okay, it's too bad. Okay, so yeah, the way we can do the optimization is that we can use the, we don't use the for loop here, we can use the, prefix, right? So this device, so if r equals to 0, then 1 else is yeah, let me think how to implement this. It'll be more simple to do so. Okay. Found false, found true. And after each row, if found, devices, this devices equal to devices r1 plus 1 if found, or r and r not equal to 0 and found, then device, this device r subtract 1 plus 1. Oh, fuck. Let me just, if 0, continue. Oh, shit, brain. Okay. If found, yes. Okay. I'll see. That's 1, right? So we can use the if device d2r subtract device d2 and d1r if equals to 0, then bins plus 1, right? Well, 8 apparently is 0. d2r d2r subtract 1. Yeah. Right, and let me try with this. Okay, it's really slow, but we pass. But there's other optimization that we can do is, oh shoot, okay. There's other optimization that we can do is actually here. Right. Wow. Okay. Date list. Put the C into it. And then for here, for R1 in devices, for R2 in devices, if R1 equals to R2, continue, and R1, C. Okay, R2, C, this is R2, for C in, for C1 in C, for C2 in R2, C. D1, D2, R1, R2, devices. Okay, so so actually we don't need that counts, right? This device R2, R1 yes, devices R2. Yeah, it actually looks like this. And since we don't care about the C, so we can just simply store the integer. And when we like to do so, we just +1, increase by 1. When we found this device, we just increase by 1. And yeah, we don't use the length here anymore. And I think that worked, right? Yes. Okay. It's pretty slow, right? Well, let me think about if we can do some optimization. I think here is pretty annoying about the code, but for time complexity, I don't think that's too bad. And yeah, I think there is a biggest optimization. I would say for time complexity that doesn't change, but in data structure execution time, I would say using a hash map is slower than using a list. So we can use a list over here actually. Devices increase by 1. Right. For I range n, rows actually. So yeah, I think that will be faster. Oh, still slow. Okay. Okay, but for current time complexity, I would say it's n times n of n times n, because we just go through each rows and columns, every element over here, and for here we just go through n squared. Also, okay, so square. I don't know which one is bigger, but yeah, we can represent like this. And for space complexity, that'll be O of n.